There's a Zen koan that goes, "Who is the great master, the magician that makes the grass green?" You know how some people have those lawns that are so bright green they're almost fluorescent? Until I was about 6 years old, I thought those particular lawns were orange, because I'm colorblind, and I hadn't yet learned that grass is green. I also thought the Incredible Hulk and the Wicked Witch of the West were just really tan. But one upside to being colorblind is that in early childhood, you understand from lived experience that there is no greenness to the grass without the presence of a great master, a magician. And that master who makes the grass green is you. Green can only happen when the grass meets your nervous system. When it meets my nervous system, something different happens, something unusual. And now when I look at grass, I use context to see it as green. And I use context to see the sky as blue instead of purple. Language has something to do with it as well. Language can change how we perceive color. Sir Isaac Newton demonstrated this when he changed the rainbow.
A double rainbow with all those colors, holy cow!
In 1704, Newton wrote a book called Optiks. And in his book, he laid out his experiments using two prisms that prove how the spectrum of colors emerges from white light. And he developed a systematic theory of how the spectrum works. Optiks is the first time we see the color wheel, which visualizes this holistic, non-hierarchical relationship between the colors red, orange, yellow, green, blue, indigo, and violet. Roy G. Biv. The thing is, before Sir Isaac Newton came along, there was no universal agreement on how many colors there were in a rainbow. It was fairly common in the West to think in terms of rainbow, which doesn't roll off the tongue in the same way. He took that spectrum of the rainbow and just added further linguistic differentiation between red and yellow to include orange, and between blue and violet to include indigo. And he did this because of an ancient sect of mystics, led by a man named Pythagoras. You know him from his theorem. The Pythagoreans were an esoteric order. They had an elaborate initiation process, so we don't know all the details of what they believed, studied, and practiced. We do know they saw mathematics and geometry as the keys to unlocking the secrets of the universe. They gave us the Pythagorean theorem, they discovered irrational numbers, whatever the hell those are. They were among the earliest Greek thinkers to propose Earth was a sphere and that it wasn't the center of the universe. They have so many hits. A personal favorite being their invention of Western musical theory. The Pythagoreans are why music sounds the way it does today. They discovered that the pitch of a musical note is proportional to the length of the string that produces it. There were stringed instruments in other cultures, but no evidence that anyone ever mathematically broke it down the way the Pythagoreans did. So they realized that if you pluck a length of string, then pluck a string that's 3/4 of the original length, you get a perfect fourth, which is like the first two notes in Here Comes the Bride. And if the second string is 2/3 the length, you get a perfect fifth, like the first two notes in Twinkle Twinkle Little Star. And if the second string is half as long, you get an octave, like the first two notes in Somewhere Over the Rainbow. Brief rainbow side quest here. In the previous video in this series, we introduced the caduceus as the staff of Hermes, and it is, but not exclusively. There was one other member of the Greek pantheon who carried the caduceus. She was the messenger of the gods, and she used a rainbow as her bridge between the divine realm and the mortal realm. This caduceus-carrying rainbow goddess is Iris. The Greeks named the colorful part of the eye after her. Okay, back to the main quest. The Pythagoreans went on to theorize that the sun, moon, and planets move around each other according to equations that correspond to the musical intervals. This idea is called the music of the spheres, and it's totally inaccurate. Planets do not move that way. Like everyone else from 2,000 years ago, they were wrong about a couple things. But Newton, being both a physicist and an alchemist, deeply appreciated the elegance of this model. If you saw the previous video, you'll remember that there were 7 known planets in his time, and 7 alchemical metals that corresponded to those planets. And since there are 7 notes in the musical scale, he really wanted to define the spectrum in terms of 7 colors. And it was totally his right to do so, because where we draw the lines on the map of the spectrum is arbitrary. You could divide colors up in many different ways, and many cultures do just that. Here's a great video about cultural color differentiation that I'll link to in the description. So since both music and color are phenomena that manifest according to their frequencies, he snapped the rainbow into 7 parts, added the musical notes to the color wheel, and published Optiks. And a few years later, we got Lucky Charms and Rainbow Road, the most diabolical track in Super Mario Kart. When you study nature, certain patterns emerge, and mystics like Newton and the Pythagoreans see these patterns as hints from the universe that reveal its fundamental nature. And they use these patterns as guideposts for how we should structure our thought in order to be more in alignment with universal truth, which they would call divinity. So when we draw out a depiction of a conceptual system, we need to be thoughtful about how that depiction might shape our mental map of that system. Remember, we shape our tools, and thereafter, our tools shape us. If we're diagramming something holistic in order to create an affordance for understanding, the ideal diagram would avoid any indications of hierarchy, because a hierarchical diagram could subtly, subconsciously skew our understanding and enforce hierarchy where it doesn't exist. Systems of thought that center around holistic relationships and cycles tend to lean heavily on circular imagery. The Tibetan Wheel of Life, the Wiccan Wheel of the Year, the alchemical Ouroboros, the Zodiac Wheel, the Medicine Wheel of Indigenous Americans, Hindu and Buddhist mandalas, not a rectangle in sight. And there aren't many rectangles in nature either. Crystals and honeycombs aside, nature is much more likely to create a circle than a polygon. One limitation of our current information tools is they can't help but impose hierarchy through their visual design. Certain types of thinking, organization, and exploration don't fit into horizontal or vertical formats without a loss of conceptual fidelity. I'm not saying we need to have circular paper or circular monitors, those things aren't practical, but I think it's very important to recognize the limitations of our tools. Before we were constantly boxed in by rectangles, our mental maps of holistic systems were more aligned with the reality of lived experience. And who knows, maybe our creativity was enhanced by this sort of axial freedom. And when it comes to nature and hierarchy, there are different lenses through which we can look toward nature as a guidepost. We can look at hierarchy as an inevitability because we see hierarchies in the animal kingdom. Ant colonies, beehives, pack animals, groups of primates. But there are plenty of non-hierarchical examples, including the largest organisms on the planet by far, mycelial networks. Those are entirely distributed. If you zoom in closely enough, you'll see cells fighting one another and competing. And if you zoom out wide enough, you'll see the entire ecosystem of the planet as a distributed network of equally interdependent systems. So the question is, where does humanity lie on this zooming scale? Are we small? Should we mimic the ant colony? Or are we bigger than that? Should we mimic the planetary system at large and operate as a distributed network? And that question drives the difference in opinion about what code to use for the operating systems of the various institutions within human civilization. But since we started this series questioning the status quo of computer operating systems, I think it's time to tie things back to that central question. How do we want our tools to shape us? What patterns do we want to emulate in order to draw ourselves closer to our ideal state? We are utterly steeped in the affordances designed by others. Why did they design them in that way? What were they thinking about? Were they thinking deeply at all? Or is the design we live with today just the best they could do under a deadline? Were they just trying to survive as a copy machine company in the digital age? How does that relate to our goals, to our vision? Our conceptual maps are filled with lines drawn by others. Why did they draw them there? Is there something important about the nature of reality that expresses itself through the number 7? Or did the alchemists just like 7 because that was the number of planets they were aware of? Would Newton have sketched out Roy G. Biv if the Pythagoreans hadn't been utterly wrong about the ratios of planetary orbits? We can't constantly be redesigning everything from scratch when we learn new information. We have to triage and prioritize. There are things that are good enough for now. They're not doing any harm, they're not holding us back. The cursor on your computer screen tilts at that left angle because of the extremely limited resolution of early monitors. It's still at that angle, but who cares? There are many things that we can wait indefinitely to fix or update. But I argue that the desktop interface for computer operating systems is due for a paradigm shift. And what should be the universal principles that underwrite a new paradigm? And are there sub-principles that should apply to specific users or use cases? How do we want to think when we use our machines? How do we want to feel? The final video will take some extra time to put together, but I hope to see you there in the not too distant future. Until then, remember that you are the master, you are the great magician, you are the one who makes the grass green. Well, at least green for you.